In today's lesson, we're going to take a closer look at convergent plate boundaries. So follow along as we do this page of notes. You don't have an additional written assignment today for science, but you will have an online quiz tomorrow. You're allowed to use your notes as you take that quiz, and it will have questions about today's video. So taking a look at convergent plates a little closer, we mentioned the fact that in convergent plates boundaries, this is two plates that are coming together. They're pushing towards one another. In other words, those plates collide, and this creates the force of pressure. The best way to help you picture this is to think about two cars that are colliding with one another. Here is a slow motion demonstration. These cars are robotically controlled, and you can see that as they crash together, they're colliding, it's creating all of this pressure. If you take a little closer look, let's replay it again. You can see that as they hit, one car actually kind of goes higher than the other one. So this one, the wheel is actually pushing up.
Look at how high off the ground
Lots of stuff is getting destroyed. So in your notes, we call that where one of them is higher than the other, we call that subduction. And what happens when two plates hit is that the heavier plate, whichever one is heavier, which is usually the oceanic because it's got all that heavy water on top of it, will sink down and get pushed down underneath the lighter one. And when that happens, crust is going to be destroyed, just like these cars were destroyed. Now, when we look at convergent plate boundaries, we call it convergent because two plates are coming together. But there's two different types of plates that we talked about: oceanic, ones that have water on them, and continental, ones that have land on them. So the combinations of those allow us to have three different types of convergent plate boundaries. We can have convergent plates where it's two continental land smashing into land. We can have an oceanic one smashing into a land, continental version, or we can have two oceanic plates coming together and smashing together. And all three of them have the same idea, but because we've got land and water involved, they will form slightly different types of landforms. So let's start with continental plates crushing up against a continental plate. When the continental plates hit one another, they're going to form mountains. And let me go ahead and show you an animation of that. I've got a continental plate over here, a continental plate over here. Let's fast forward through time. And you can see it's creating all this pressure, and the crust itself is getting destroyed, but it's getting pushed up higher, and that's where we get this crumpled mountain effect. So the Himalaya mountains are actually the highest mountains on Earth. The tallest land mountain is Mount Everest, is found in that mountain range. And it's happening where the Indian plate is pushing up against this Eurasian plate. And that Himalaya mountains, believe it or not, these mountains are actually growing taller as those plates continue to push together. The mountains grow about 2.5 inches taller each year as they continue to crush against one another. The next type of convergent plate is where we have an oceanic plate hitting up against a continental plate. And you'll want to take a moment to pause this video so that you can copy down this section of your notes. Let's go ahead and take a look at what happens when that oceanic plate hits the continental plate. And again, the oceanic, even though it looks thinner, this is water, which is very, very heavy. So it's going to be the one that's subducted or pushed underneath the continental plate. Now, as that plate is subducted, this gets destroyed. It gets melted down in the mantle. And as it does that, you can see that it creates this little hot spot here. So there's extra pressure in this section of the mantle, extra heat as this rock is pushed down. And when it does that, it forms this extra hot spot that eventually pushes up. And that's where we get these volcanoes that form. So looking at volcanoes, probably the most fancy or the most famous example I can provide you for a volcano that formed that way is Mount St. Helens. So here you can see our oceanic getting pushed up against the continental, and as that oceanic crust gets destroyed, as it's subducted, pushed underneath and gets destroyed, it creates this extra hot spot, pushes up through the crust and creates these volcanoes. So Mount St. Helens is a very famous volcano in the United States. It's in the state of Washington, way out here in the Northwest. And if I zoom in here on Google Earth, you'll see that we have it formed by plates. So we have an oceanic plate here that's pushed up against our continental plate, trying to keep it centered, and that has created this little hot spot. So here is, and you can see there's a couple other volcanoes around this area too, but Mount St. Helens erupted in 1980, and it was such a violent eruption that it actually blew its crater off and created huge amounts of dust and that were released out into the air. You can see the crater's been partially broken off by that. And it actually changed the weather because there was so much dust in the air that it made it cooler than usual. The other thing that forms with these plates is a trench. So you can see that trench again is this narrow valley. And a good example of a trench that's formed by oceanic and continental plates is the Peru-Chile Trench. So it's, again, this area right here, and I'll show you it on Google Earth. So here is South America. We have a little tiny plate here called the Nazca Plate, and then we have the South American Plate. And that Nazca Plate is part of the Atlantic Ocean. It's getting subducted or pushed underneath the South American Plate, and you can kind of see it from here. This is this really low-lying oceanic trench. And it's just this deep gap in the Earth's crust. It's very narrow and skinny, and that's what that would look like. Our final combination would be an oceanic plate colliding with another oceanic plate. And this is going to be very similar to what we saw with an oceanic hitting a continental plate. The only difference is that one of those plates is underwater, so the stuff it forms is underwater. And again, you'll want to take a moment to pause this to copy those down. Let's go ahead and take a look at an oceanic plate hitting an oceanic plate. The same idea as what we saw when this one was continental. Again, the heavier of those two crusts, which is the older type of ocean rock, will get pushed underneath the other one. And as it does that, it creates this little hot spot where there's extra pressure on this section right here of the mantle. And that's going to break through, that extra heat and pressure is going to break through to create those volcanoes. And I'm going to slow this down just a little bit and rewind it so you can look a little closer at those volcanoes. You can see that as they start to form, they are underneath the ocean, but then slowly, as they erupt more and they get more and more rock added to them and piled on top, they do eventually break above the surface of the Earth and cause islands. So as I mentioned here in your notes, when the oceanic crust collides with the oceanic, it forms this trench. It's an ocean trench, and then it forms volcanoes that are underneath the water, and they start underneath the water, but as they continue to erupt, every time a volcano erupts, it adds new rock. Usually, it adds new rock that hardens and cools and makes the volcano taller. And so eventually, they will break above the surface of the water and form islands. Probably the best known example of that would be the islands of Hawaii. So here's an oceanic crust hitting an oceanic crust, and it forms, again, these underwater volcanoes. You might remember hearing in 2018 about the volcano Kilauea in Hawaii, and in 2018 it had this major eruption and they had to evacuate part of the islands over that. So let me show you Hawaii. Here's the United States way over here, and as we zoom in, it's pretty far away from the United States. Here are the islands of Hawaii. There are several different islands make up this state, and you can kind of see here's underwater volcanoes that haven't erupted enough to actually form land. As we zoom in on Hawaii, you can see that it's really just a bunch of volcanoes that have erupted enough to create these little islands. So there are your Hawaiian islands that are formed by that. And then, as we said, the other thing that forms in addition to volcanoes is an oceanic trench, an underwater trench. And the best example I can show you of that is the Mariana Trench. This is actually the deepest place in the entire world. It goes 7 miles deep, and it's found off of China. I'll show you it on Google Earth here in the Philippines. And there it is right there. and it, like I said, goes 7 miles deep. There was actually an exploration a couple years ago where a scientist created a special submarine and went all the way down 7 miles deep, not quite to the bottom, but pretty close to it. And that ocean exploration mission was called Challenger Deep. If you want to study more about it, it's pretty fascinating. But that is the Mariana Trench, which, as you can see, is formed by an oceanic plate here and an oceanic plate here, and they're pushing up against one another in a convergent plate boundary, and one is getting subducted underneath the other. You might actually have heard of ocean trenches in one more. If you've ever watched the movie Finding Nemo, there's a little scene here where they are actually going into an oceanic trench. So I'll close out our video with this little quick clip.
Dory saying, Dory, to swim, Dory, when you want to swim, you want. See, I'm gonna get stuck now with that song. Now it's in my head.
Sorry.
Dory, do you see anything?
Ah! Something's got me!
That was me, I'm sorry.
Who's that?
Who's that? Who could it be? It's me.
Are you my conscience?
Yeah. I'm your conscience. We haven't spoken for a while. How are you?
Can't complain.
Yeah.
Okay, so they're down here in the bottom of an oceanic trench, and as you know, if you've seen this movie before, you know that eventually they see this glowing light that they call their squishy, and it actually turns out to be a kind of horrifying fish called an anglerfish or a lanternfish, which, yes, actually lives down in oceanic trenches. So Disney didn't make that up. It actually is based on a true part of our ocean.